Hi. My name's Harrison Moore. I'm a technical artist at Epic Games. For the last 2 years, I've been working on Paragon, and I've been with Epic for 7 years now. And Epic's been a company for 26 years, and in that time, we've made over 40 games. And through all these games and products that we've made, we've become known for the visual fidelity that we bring. So a couple of years ago, Epic began to develop its latest IP, the third-person action MOBA Paragon. We entered early access in March of 2016, and we've been a live product ever since. The pillars of the game's design revolve around having a wide selection of unique hero characters, competitive MOBA gameplay, and hyper-realistic visuals. And to increase the challenge on the artist, we're running at 60 FPS on the PlayStation 4. And the challenge on the Paragon's character team is pretty specific. We need to release a hero every 3 weeks. The characters need to hit a hyper-realistic visual quality, and the characters need to be set up in a way that allows us to create skins and variations of these characters very quickly. Also, our source data needs to be very organized. Paragon is a living long-term product, so the chances of someone else needing to edit your character a year or two from now for visual upgrades or for a new skin that we're going to release is very likely. And I'd like to play a quick video from one of our characters. This is Aurora. She's a character with a lot of unique material challenges.
What a charming little world. I'll take it. Until next time.
All right, so Paragon launched in March of 2016 with 13 heroes. And since then, we've released 16 more characters for a total of 29 current characters. And for those 29 characters, we've released over 120 skins. And when it comes to pushing out this many characters and skins, speed and quality, they go hand in hand. The faster you can nail the basic look of the character, the more time you have for polish, feedback, and iteration. And the higher overall quality you're going to be able to achieve with your end product. We began honing in on what the appropriate workflow would be for Paragon. And we knew that we wanted agility and flexibility to be the main aspects. And we found the easiest way to achieve our goals was by simplifying it as much as we could. This is a quick snapshot of the general character workflow for Paragon. And we ended up using Substance Painter as a central file that packages everything up to go into the engine. We encourage our artists to work our texture artists to work in whatever package that they want to work in to texture. And then they take that information, they bring it into Substance Painter, and they export it from there. The next artist that works on the character can take the files out of Painter. They can work on them in a different program wherever they want, and they bring them back in when they're done. They also have the option of just working in Substance Painter, which many of us do. And they can just edit everything directly there. And when an artist wants to see the results of the changes, they can quickly export all of their masks from Substance Painter and into the Unreal Engine with just one click. But before we go into the Painter workflow any deeper, I want to go over one of the key features in Unreal Engine that allows us to do this, which is UE4's material functions. Material functions in Unreal are pretty versatile, and they serve a wide variety of uses. But in Paragon, we use them as a massive tiling material library. And the tiling materials in Paragon are very simple. We have every attribute defined for leather, ice, whatever, and they're all designed to be base white. They're all color neutral, and they're all very generic. The artist will tint the material function to whatever color they want it to be later on in the process. And they can range from a simple leather, like you see here, to a more complex ice. But every material function, no matter how simple or complex, is designed to have a set of customizable external outputs. Every material has tint, grime, scratch, and tiling controls, and they can also have unique inputs that are specific to that material. So at this point, the Paragon material library is pretty massive. For every character we make, for most characters, we only have to make maybe one new material. This image only shows a very, very small fraction of our material library. This is like our 30 or so favorites. But the full tiling material library that we have for Paragon is at a bit over 400 tiling materials. So I'm going to open up the engine real quick, and we're going to take a look at some of them. Put it over here. All right, so this is our calibrated lighting courtyard that we use, and every single character that we work on in Paragon, we work on in this map. It's not artistic. It doesn't necessarily have to look great, but we've calibrated it to the light, and we've actually released this. It's called Advanced Lighting. It comes with the starter content in Unreal Engine. Now, we've personally made a couple of adjustments to it. It has Paragon's post-processing and tone mapper in here, but other than that, it's pretty much the same thing. But its accuracy is not the most important thing. The most important thing is that we work on everything here, and we trust it. And what that means is it becomes the baseline for all of our characters. So if later on we have a change in lighting, or we're doing marketing assets and we're lighting the characters all nice, if someone later on comes to us and like, hey, I think this is too bright, this is too dark, I can't see it, we can tell them, no, we trust this. We've looked at it here in our lighting courtyard. Check your lighting, because you have something weird going on in your post-process. And it allows us to take the areas that we might fail or make mistakes and reduce those. All right. So if we look at this, we can see that this just has a bunch of spheres with some of our tiling materials applied to them, and we'll go through and look at some. Over here we have like some cloths. So we have wool, nylon, and fur. Back here we have some rubbers. So we just have like generic rubber, latex, and then something that looks a bit softer. We have our glass in Paragon. We can't use translucency. It wouldn't hit frame rate. So we actually use opacity masks, and we use the dither opacity mask function for all of our glass. And so you can see here, it's actually just like a lot of dots, but once aliasing the temporal AA takes care of it, it looks pretty good. Here we have some car shaders, some clear coats, some metallic flakes, and then back here we have all of our metals, aluminums, gunmetal, and you'll notice that they're all fairly broad. These are all of our material. Our material functions are made to be very flexible, and if the artist wants to make more specific ones, they can make adjustments to, or they can duplicate a new one. But we start broad, and we only get specific when we absolutely need to. And a lot of this comes down so that we can optimize better. So if we have, say a character has 2 or 3 metals on them, for instance, if we find that we're over our shader instruction count, it's better if you're using a more generic metal, because then you can kind of just, instead of having 3 different metals, you can combine them all into one metal and just tint them into 3 different colors and adjust the roughness. And you generally get the same effect for much cheaper shader instructions. And here we have some plastics, leathers, and so on. So we'll open one up. This is low contrast hard metal. This is one we use on everything. Its name is pretty self-explanatory in that it is a metal and there's not a lot of contrast in diffuse. And this means we can use it. I'll move this over here. We can use it for pretty much most of the metals in the game if we really want to, as long as they don't need to be too dirty. And you can see here, these are the external artist-friendly outputs. So we have roughness modulation, tint, and tiling are the main ones. And then we have, you can put in a scratch mask and a grime mask for dirt. And so what this allows us to do is an artist can very quickly come in here. And so right now it's kind of like a titanium, but very quickly an artist could come in here and make it into like a nice gold pretty fast. And if he had, if he actually had two metals on his character, he could add a lerp and have a mask drive this lerp, and then he'd be able to do as many metals as he want for fairly cheap shader instruction count. So if we go into it, we can see that it's fairly simple on the inside, and we have to keep all of our individual material functions, for the most part, pretty cheap, because the real cost of a character is limited to 350 shader instructions, like Zach was talking about. But that can really rack up once you design these characters that have, 5 or 6 different layers on them. So you have to keep your layers as basic as possible. So all this is a couple lerps with masks for scratch and grime that are driving them. And the grime just makes it darker, and the scratch is actually just a multiplicative of the tint, the base tint that they're throwing in. And you can see it's base white, so it can be whatever color, and the artist doesn't have to be competing with tinting some sort of blue input or some sort of green paint, right? And so that's all there is going into this one, and this is what a lot of our material functions look like. They're very simple. But we can also, if we go in here, we can look at a more complicated one, which would be our fur. And so our fur is a more expensive one, and it has a lot more going on. But on the outside, to the artist, it actually doesn't have much more going on at all, right? It actually has less than our low contrast hard metal. So we got tiling for the fur, we got some roughness modulation and some tint, and it doesn't even need a scratch, right? So the artist is still artist friendly, even though underneath the hood, if we were to open it up, it has a lot more going on in here, right? So we have all the post-process in here, or the parallax occlusion mapping is going on inside this node. And other than that, we're just kind of just driving these same values with these tints, the grime, and the normal map adjustments. And that's how most of our functions look. So, but you'll see that if we were to compare the costs, so if we were to go to our stats and look at our material instructions for both of these, the fur is significantly more expensive. And what that means is that the character artist needs to be as careful as possible when using this fur, and they just can't use it with a bunch of other layers. And so what we've done to mitigate that in this instance, and that we use all the time in Paragon, are these quality switches. So we have high for PS4 Pro, and default is the same as high, but medium is PS4. And so if we have something that we just can't afford, we'll just turn it off in the shader. And we have a bunch of these that just go all throughout the Paragon shaders so that we don't need to do any optimization on the high end. All right. Cool. So we'll go back to this. And this brings us to the textures that we're painting to distribute all of the material functions. Most characters in Paragon are not using a directly painted diffuse for anything other than skin. We're instead painting a collection of masks that are defining the material IDs and the variation within those materials. So every character has two standard types of masks. We have our scratch and grime mask, which is on the left here, and that has one character for one channel for all the scratches, and one for all the grime. So here that's the green is all scratch and the red is grime. The mask also has a flexible slot in the blue channel that we use for character-specific things like rust, tattoos, or decals that the character might have on them. The material ID mask on the right defines all the material breakouts. So each color denotes a material function that will be rendered in-game. So the red might be a plastic, the blue will be a leather, the green here is a metal, and so on. So just to further elaborate on the scratch and grime, we add the scratch mask to add wear to the characters and to highlight their edges for important forms. And we use the grime mask to add dirt and roughness variation to the character, but also to darken areas that need to be pushed back. These two masks are actually where we spend most of our time when we're working on the characters. They really go a long way towards defining the look of a character. Some characters in Paragon are very, very clean and don't need much of this at all, while others, like Onyx Scrux here, are very dirty and have a lot of work put into them. And this is a good example of Onyx Scrux there before the scratch and grime masks have been added. You can see that there is still some roughness variation there. That's just tiling information that's part of the material function. But once we add the grime mask, we're really adding a lot of much bigger forms into the roughness map. And we're adding a lot of variation to them. And Substance Painter has become the easiest way for us to store all of these files and masks together. We have a master file for each character. So inside of our Painter file, all of our characters' texturing data is stored. All the masks, patterns, and baked textures all live here. And the big advantage is that these files can be made in any other program that the artist is comfortable making them in, and they can be brought into Painter later. So if an artist is more comfortable drawing a pattern or masking in Photoshop, that's fine, and they can bring that into Painter later to be stored. And our general workflow revolves around creating a single layer in Painter for each material that will end up on the final character. So we just break out all of the masks and we assign them a flat color. It doesn't even have to be the color that they're going to be in-game. Color roughness and normal maps are not important. We're not doing any look development in this environment. As long as the breakouts can be visualized, that's all we need. And we just put the scratch and grime mask at the top with a black and white layer. It's a simple setup that allows us to easily visualize the final effect on the character. And after everything has been arranged onto the character, every layer is assigned to one of Substance Painter's user channels. For instance, you can see here in this image on the bottom right, user channel 0 is his red or his armor. User channel 1 is Kevlar. User channel 2 is steel, and so on, all throughout the character. And what this allows us to do is that using Substance Painter, we can make an export preset, assign all of these to a channel and a texture, and then we just click a button and it is imported into the engine. And so we can see the results of all of our changes very, very quickly. And so at this point, we can rapidly iterate on all of our characters there's no downtime or middle steps, or we don't have to go into Photoshop and pack everything at any time we want to make a change. Everything is one click away. And the process to get everything set up to this point for every character is honestly only 2 or 3 days. And our texturing timeline is about 3 weeks. So that gives us 2.5 weeks to polish the character, to spend time fiddling, changing things and adjusting things, and really making sure we're making the best character possible. And it also enables super quick skin generation. So because we have everything in one file, all we have to do is duplicate that file and just move things to a different user channel and quickly export those new masks, and we have a new version of the character with different masking breakouts very, very quickly. And all we have to do, if we want their armor to be different here or make it glossy like the one on the right, is we just change the material function that color is representing. So we'll go into Substance Painter here. And this is what a character looks like in Substance Painter. So this one actually belongs to our character, Lieutenant Bellica. And this is one of her effects meshes. But this is a good example that we can use to quickly... This is what a character looks like, right? And you can see right off the bat is that it doesn't look very good. This doesn't look anything like what the final character looks like in game. And that's because there's almost no point trying to make it look like the character in game. We don't have the same lighting. We don't have the same tone mapper. We don't have any of our material functions. So we're not going to spend any time trying to visualize that or trying to approximate it. We're just going to try to get things from Substance Painter into Unreal as fast as possible. And so you can see the way it's set up here in the masks is that I just have a different single layer for every single material that it will be in the engine. So we have panel plastic, glossy plastic, metal, etc. And you can see here that each one is assigned to one of these Substance Painter user channels. And what that means is that if I were to hit C, I can cycle through them all. I can visualize them all. And I can know where everything's going to be. And once I have that all set up, I can come in here and we can make Bellica's drone. And I can make a couple masks. And as we're making these masks, I can then assign these user channels, each one to a different color. And we're going to skip the alpha. If you can get away with not having anything in your alpha channel, it is great for optimization and really cuts down on texture memory. The alpha channel in Unreal is just as expensive as the other 3 channels combined. All right, and then we'll come in here. And we'll add our scratch and grime here. And then that would be all I have to do. Is I can use this now to export. And we can see the output here is that's all I need. All right, so these are what all of our masks look like. Now, we can go into Unreal, and let's take a look at how we're using those. So this is what a character material looks like here for Paragon. So over here on the left, this is where all the action's happening, right? These are where we placed all of our masks. So these 3 here, these are the material ID masks. And then we have our scratch and grime at the top. And they're hooked into this function, the 10-layer blend. And it has a baked normal at the bottom. And then after that, we're just stacking on masks and hooking them into these material functions. So you can see here at the bottom, it's got some rough plastic. It's using a colored metal. And then it's using a rubber. And we can go up and we can adjust all these. And that's how it's set up. So if I wanted to make a skin later on, I have options, right? I could come in here. I could, if I were to look at this, I could take this red. I could move, say, this section. I could move it to the blue channel. And I could come in here and I could set this to... Or I can set this to a metallic flake, rehook in the color, and hit apply. Well, there we go. All right. So, and then as soon as it compiles, we're going to have a new skin for this character. And I can dupe that off, and I can make the color adjustments, or if I take it to my lead and he says, that's not what we're looking for, we need we need it to be more rough. Those changes are very, very easy. So another thing we can do for even faster iteration that we've started doing a lot lately is we can take all of this and we can actually just make a specific material function that just consists of all these instructions. And that simplifies this even more. So if we come in here, we make a material function. We can name it Bellica Clear Coat. We can just throw all of this information in here. And we can add a function input. We can name it, say we want to use our scratches. We can hook it into the scratch. We can save it, and then if we find the... And actually, it simplifies the character materials even more. So I can take this, I can hook in our scratch. And now, this change that I make, or any changes that I make to this clear coat, will propagate to all of her different draw calls. So in this situation, we only have the drone. But if it was a full character, it would have upper body, lower body, head, etc. And anything that needed this version of the clear coat is now all controlled by this one material function. And we can clean this up and we can get it out of the way. Another optimization that we could do to this specifically is to eliminate any redundancy. So, for example, let's say we didn't need our grime or our dirt, it's almost done compiling, to be unique. Say we only need brown dirt through the whole thing, or we don't need any rust. So we don't need these individual grime channels. So we can actually just come up here to the top, and I'm just going to make a quick one, which, let's say we just want brown dirt. And I could take the dirt, I could hook it up here at the top, and then disconnect this grime mask from anyone that doesn't need unique grime. And that'll really lower the shader instructions a lot. So we were at 318. Let's see how many material instructions that'll be once it's done compiling. None, apparently. Great. There we go. Oh, it went up by one. Fun. Way to make me look good. All right. So, really though, why are we doing this? I guess is the real question. So why do we spend so much time making all these masks, and why don't we just paint a diffuse channel for every character and a roughness and just hook all that up? And the real advantage here is texture resolution. Because we have all these tiling materials, you can tile them as many times as you want, and it's free. It doesn't cost anything. So you get as much resolution as you want out of these materials, and you can look up, you can get really close up, and they don't break down. The other real advantage is that we get free graphical upgrades to our game for the duration of our game. If at any point we look at our leather and we say, oh, why does all of our leather look weird? Like, it's a bit too shiny, like the roughness seems off, or there's too much roughness in the cracks of the leather, and it should break up more. It's just not working. We can go and adjust that, and any character that has ever used that leather gets a graphical upgrade for free. Same with optimizations. If we make an optimization to one of our materials, every character that uses that material gets it for free. So what are the disadvantages? The real disadvantage is that it costs more shader instructions to layer on all these materials. We get around that by breaking up our characters into more draw calls, but then you have more draw calls. So it's a little bit of a balancing act, and you have to be careful with it. The other thing that we run into is that there's just a little bit less artist control for grime, specifically. So you can't have a character that has a bunch of intricate, like, rust and dirt and oil stains and coffee spills all over him. You have to keep it simple, and you have to know where to pick your battles with this. So once this workflow is in place, the artist only has a few real challenges left, though. They need to nail the color, and they need to nail the values on the character. They experiment with different material layers to make sure every individual material works well with the other ones. And they need to paint a nice-looking scratch and grime. And they need to paint the skin. And the real challenge remaining is the skin. And human skin is always a challenge because we are all familiar with it and we look at it every day. In Paragon, we also have to hit certain performance requirements. So you can't go overboard with our shader cost to achieve the realism, right? So when it comes to painting skin, you really have to make sure that you have proper lighting calibration, and you have to pay attention to the details. If one thing is even just slightly off, everyone can notice. So I'm going to walk you through making a Paragon character's skin one by one. And this is how it starts. So it's a really ugly, uncalibrated facial scan. And so we've taken a rough facial scan of a model, and we brought it into ZBrush, and the modeler did a bunch of pulling, and it stretched everything, and they didn't keep the facial scan wholly intact. So we kind of get what we get, and sometimes it's better than others, but most of the time it's not very workable. So you can see in this output, for example, it's very yellow, and because of the lighting conditions that they took this scan in, there's a bunch of scars and like discoloration that we really don't want for our final character. So we nuke all of that. And the first step is just to get the skin tone of the character, right? There are a lot of factors that go into this, the character's background and ethnicity. For Aurora, we wanted her to be extremely pale, but with just slight peach undertones. And this is the most important step in the entire process. Getting a skin tone that reads correctly and it's not too yellow or it's not too orange or something in a wide variety of lighting conditions is very important. And it has to play well with the other characters in your game. It can take a lot of work, and it's something that we're tweaking continuously. And this is also where the lighting courtyard that I talked about earlier is very helpful. Because all the characters are in the same lighting environment, we're not fooling ourselves. And so at this point, we load the character into Substance or Mari, and we start projecting new skin onto the character. And most of the time, this is from photo source that has been calibrated in a flat lighting scenario, and it doesn't have to be from the face. In fact, I like to use the skin from someone's back, and you just want tiling skin information from human skin. And once we bring that in, we can bring in some of the photo scan data on top of it. Generally around the eyes and lips is what you bring back in, and then you color correct the old photo scan data to your new calibrated skin. So at this point, we add what I like to call structural color. These are colors that define and differentiate the surface on the face. We add a pink-red color around the character's tear lines. We add a slight red around the ears, and we darken the inside of the nostrils. You can see here I also added just some really quick roughness values and subsurface scattering values, and that's so I don't have to adjust my color later on once I add those. But we'll polish those more in depth later on. And after that, we start making subtle adjustments around the character's face. This stuff is normally barely noticeable, but our brains can pick up on this stuff if it's missing. So some key colors here are red on the cheeks, yellow on the forehead. There's generally a subtle gray gradient going down a human face, and there's generally a purple-green gradient under your eyes, and a slight blue-gray tint on the sides of your nose. And I also added some eyebrows here, so you can start getting a sense of facial composition. And that I cranked this up to 11, right? So we can see everything that's going on in this step. So at this point, we take a detour from polishing the diffuse map, and we're going to work on the other maps. So we add subsurface scattering. And the way we generally like to use this is we make a subsurface scattering profile with a really big radius, something around like 10, right? Way higher than what we're generally going to need. But then we paint a mask that will set it down and crank it all the way down to like 0.2. But we'll go back in and we'll paint and increase the subsurface scattering around the nostrils and the cheeks and the ears, so that those areas really get a lot of bleed in the subsurface. And so that's the input. This is the input into that step. Basically, where it's bony and there's less fat, we paint less subsurface scattering, and where there's generally more fat on someone's face, you're going to crank it up. She is wearing makeup, and so wherever she applied makeup, I generally tone the subsurface back. And then we'll move on to our other maps, which are roughness and specular maps. On Paragon, we have a specular map, which is on the left, and that provides more chaotic information. It's low contrast, and it gives more of the sense of environmental variation, such as grease buildup, etc. But the effects from this are very subtle. We want to keep this around 0.35 as our baseline specular for human skin. And then we have the roughness map on the right, and that map provides more structural information. And what we generally do is we paint very broad gradients for nose values, eye values, and it's very general. But then we combine it and we overlay a cavity map on top of it so that we get pore breakup, etc. And combined, these two maps work together to get the subtle variation we're expecting on someone's face, while also keeping the roughness correct on a broad scale. So our roughness map, this is the output from that. It's very simple, and it generally stays the same on most of our human characters. We go in with soft brushes, and we just define the general areas. And then this is the input for that. So after the roughness map, we add the specular map. This map has a lot more noise going on and random variation in it. And it just is grease and oil buildup and dirt on the skin, and it's very, very low contrast. And this is the input for that. I've just cranked it up, and I cranked up the contrast because if I were to show it without it, it would basically look like nothing. So after all of that, that's a pretty good base for a female character. So for a female character, this is where we add makeup. And in particular, Aurora's backstory is that she's a witch that lives in the mountains alone. And we wanted her to have a pretty thick layer of makeup on and make her look a little bit sinister. And the best advice I have for makeup is to watch other people do it. And honestly, the internet is filled with makeup tutorials and makeup trends or magazines or all of that stuff, because the application process that they use in real life is the exact same thing that you're gonna use in your painting in Photoshop or Painter. It's the exact same. And it's really amazing how much of that those like beauty guru tutorials translate into painting makeup on a character. So at the end of the day, the visual polish in Paragon revolves around breaking all of our tasks into simple steps. We can continuously be tweaking and adjusting the trajectory to make the highest quality product that we possibly can. It also gives us flexibility. There are artists from 4 different countries working on the character texturing team for Paragon. And with this setup, we can all work on each other's work very efficiently and flexibly. So thanks, guys. We can do Q&A. We got about like 10 minutes to do Q&A. So if you guys have any questions, I'd be more than happy to answer. Yeah, in the middle. So the skin is the only one actually. So even on the environment, it's all using this method, right? It's all using blended. The only thing that we've gotten away with is, no. I'll say generally we stick to this pretty rigidly, even for the smaller props. In the case of a smaller prop, generally you can we merge them onto the sheet or to the draw call with other assets, and we're using HLOD anyway. So our HLOD system will combine those. So on the right.
How are you considering the pores with the mid mapping? Because as the character is far away, it tends to actually mid map and lose the pore, which breaks the spec, and also the subsurface scattering. It tends to actually makes the skin look like wax. Are you doing anything with custom mid mapping?
Yeah, so actually, the solution that we use for that is actually our composite normals inside the engine. I can actually open that up real quick. And the way that you set that up to make sure that specular and roughness falls off correctly with mipmaps and responds is, let's see if I can get something here. Yeah, we'll use our leather. So if this is our leather texture and the alpha is the roughness, you can see here on the right, the composite texture, we have the normal map. And so if you hook in the correct normal map here, it'll actually adjust your alpha channel, which it's assuming the roughness. You can change it to any of these other ones. So if you have your roughness in the red channel, for instance, and this is specifically for roughness fall off with mipmaps. And so just hook this up to whichever channel is your roughness map, and it'll ensure that it doesn't look waxy. Yeah, so that's how we tackle that. Anything else? Sure, in the front. Oh, okay. Wait. We have a mic. Sorry.
Hello? Okay. Out of curiosity, what is the texture resolutions you use for various assets on different characters or models around Paragon?
Yeah, so we work on everything in 4K, but all of that gets instantly taken down. So normal maps are the only thing that stays at 4K for characters. But that is adjusted per console and per quality. It's not at 4K on PS4. And we just set that all up in our INI, and we set everything to designated texture groups here on the right. So you can see here we're actually just hijacking the weapon texture group for all of our character material functions. And so that makes sure that all of our diffuse maps, they'll get normally cut to 2K on high-end PC or 1K for PS4. And then the actual like normal map and the masks are normally higher than that. And we just set them to the character texture group. So I think they're 2K and 4K again. Yeah. Any other questions?
You mentioned a calibrated lighting environment. I'm just wondering if during your asset creation, HDR ever came into the equation, and also wider gamut color spaces.
It hasn't for Paragon. There are a couple people that we basically have that have HDR and all that at their desks to double check everything. But no, we work on everything in just regular monitors. Yes. Okay. We got maybe 2 more. Here in the gray shirt in the front. Thank you. Oh, well, she's... Yeah.
Regarding the heat map, how you keep the position for the material ID map after you have a heat map filter?
Sorry, so you're saying how do we keep the map from getting blurry, I guess? Since you
have a heat map, and we use a material ID map after the heat map filtering, how you keep the precision of the material ID?
Well, so to a certain extent, we just let the map do what it's going to do, and hopefully you're far enough away not to really notice. But we do have the MIP settings, and everything is set to sharpen here, so at least it won't get blurry. But yeah, there are a couple precision issues, and we just try to hide them as best as we can. Generally, what that involves for characters is if I were to open up this is we set a flat black with a roughness set to 1 at the bottom, and so that way if there are any precision issues with the mask, at least it's black and it's not showing some sort of subsurface skin underneath. Okay. Is that what you're looking for? Yeah. Okay, awesome. Any other questions? Back there.
One last question. I'm just wondering, do you ever use UDIMs in your authoring process? And if you do, what do you then use to consolidate them before they go into the game engine?
No, we don't use UDIMs for Paragon. Nope. Yeah. All right. Yeah, I think we got time for one more.
So if I'm understanding correctly, you don't use material instances to tweak things by the looks of things?
So there are generally no. There are certain instances where we use material instances. For example, if a character's upper body and lower body have the exact same textures on them or the exact same collection of material functions, for example, then we'll get lucky and we'll make a material instance out of it. But that advantage is lost if, say, the character's pants have a lot of cloth on them and that's not on the upper body. We can't make an instance of that. Yeah, I think that's about it. Thanks, guys. Have a good day.